few words about me. I'm gonna deliver the opening keynote, so I promise it to be pretty short. The idea of this keynote is to lay the groundwork so that you better understand what we're gonna be talking about in the upcoming things. I started my engineering career in 2007, which is quite a bit of time ago, but I was always curious about very different technologies, and as you can guess, my probably last departure was into game development, game engines, and all of those stuff. That's why I guess I'm giving the opening keynote. I myself have developed, I'd say, 2.5 game engines, 2 of which were terrible, and the second half was okay, but I developed this along with the team, so I'm not sure if that can be attributed to me, but I prefer to think I at least gathered some understanding of how things are working there. So please allow me to do a bit of a questionnaire here. Could you please raise hands those who work in game development, developing games, not the server side, just games? Okay, it's actually a fair bit. And out of those, any of you who work on the engines, engine code, low-level plugins, whatever? Okay, great. There are people. So, okay. So for those of you who are more into the game engine things, my keynote might be a bit light, but brace yourself for the upcoming ones. You might hear much more interesting things, and of course, I'm more than happy to address any questions. So, since we're going to be talking about the game engines, right, let's first of all define what the game is, because as you know, the games are a pretty diverse topic, right? You can remember Game Boys, you can remember arcade machines, like whatever. So in this talk, we want to consider the game that is something that is real-time, interactive, graphics-based experience that runs on the conventional hardware. So again, arcade machines, Game Boys, we're not considering that. It doesn't mean those games are worse or whatever, we're just, out of the scope of this talk, right? We also want to explore more or less modern design, maybe not, the cutting-edge recent advancements and whatever, but at least something that is usable today and in some foreseeable future. And we won't be bounded by 2D or 3D. As you will see in both graphics and physics, there are many approaches that are shared. And as we are looking forward to give you a very nice and solid intro into that, that also shall become obvious since we go through that. Just to, break everything down and make sure we're on the same page, right? When we say that we consider the game to be a visual experience, we assume that we're going to be having dynamic scenes. So we don't want to just, show a pre-rendered video or whatever, or just static imagery. Although some of you can remember games like Myst, for example, which was just built off the sequence of statically pre-created images, and nevertheless it looked like a great game, and it was a great game, right? We want this experience to be interactive as well, as in it's not a rail shooter, right? It's something that reacts to the user input. The form of the input does not really matter, whether it's a mouse or a keyboard or your gestures in VR, whatever. There is an input and the game reacts to it. We want the game to be realistic, right? By realistic, I just wasn't able to find a better word for that, to be honest, but by realistic we mean that it has to have this Turing feeling of the game somehow communicating with you, not just doing random things in response, right? So it doesn't have to be a real universe, it can be something completely out of this world, but we want it to be somewhat believable, if you please. Audio, let's have it. Maybe we do, maybe we don't, it doesn't really matter, and obviously there might be many other bits in the games that are mostly out of the scope of this talk, but on the after party and on the break, we are more than happy to discuss those bits as well. Okay. So once we agreed on, of what the game is, let's try building the game, right? Let's say we don't know anything about the game engines, we don't want to download Unity, whatever, we just want to build a game, right? So on the screen you can see a game. Technically it is a game. It does break a few constraints that we put in there because it's not really visual, but hey, it's interactive, right? It responds to the user input. It kind of plays with you. You have to guess the number. And, it can pass for the game, and maybe we can just gradually build upon that to build our nicely looking game that we've been discussing, right? Sounds easy. Everything is just a loop, right? Everything down to the very transistors in the processor executing instructions is just a loop. It's just things that go on and on and on. So is this that easy? You can argue it is, but once you get to the details, it actually gets much, much more complicated, right? So what's complicated? Well, first of all, rendering in 2D or 3D setting is pretty hard, right? Rendering in general, like if you want to produce a picture that looks real or photorealistic or just nice, it's really hard. Even if you kill realistic, it's still hard, right? So why I'm saying that? Okay, so what would you need to render an image in the game? First of all, you'll probably need to use some sort of graphics API. You can try building your software rasterizer, you can do whatever, but if you actually want to do this game and deliver it to someone and play it, you'll probably have to learn how to interact with, you know, OpenGL or WebGL or DirectX or Vulkan or Metal, you choose, but you gotta know some sort of the API. Not that they're particularly complex to learn, but that's, you know, that's something to learn, and it has its own rules and worlds, and Alexei is actually gonna go much deeper into that. Apart from that, you also need to learn one more language. I'm sorry to break this to you, but you'll have to write shaders. You can go this far without using any custom created shaders, but again, assuming you're building the game from scratch, you know, you'll have to do it at some place. And you will also need to know at least a bit of linear algebra. All these boring things that have been taught at the university, and many people, I'm sure, just like me at the times, didn't really understand how this can be useful, actually appears to be, you know, quite a foundational bit in all these things. So that's already a few things to unpack, right? You might say, okay, I'm just gonna go to 2D. 2D is gonna be easier, right? Well, again, you'll probably need to use some sort of graphics API. Unless your game shows, you know, just two images changing or whatever, you very quickly run into performance concerns and you'll have to use some graphics API. It's true that you don't need linear algebra in, like, you know, all its full-blown glory, but you'll need some bits of it, for sure. Just because, again, you're gonna be composing dynamic scenes out of your 2D objects and whatever, and you'll have to do some transformations and stuff like that. So, you know, sooner or later you arrive to pretty much the same requirements. And you can go much further without using shaders, but once you want to do nice effects in your games, it will very, very quickly turn into the fact that you'll actually need to use the shader language there as well. And that's about rendering, right? So again, quite a bit to unpack. Obviously, it's not doable. People do it. People develop engines. People develop games without engines. But it's just rendering, right? So what else we need? Well, we'd like to have some simulations in the game, right? Ideally, in most games, you'll need physics. It doesn't mean that the game is going to be using physics. Again, you might just need some queries into the world. Even if you fake physics like completely, you might need whatever is intersected by array, or how the objects overlap, or whatever. It's just going to require some sort of a physics engine, maybe like very limited, and maybe you're just going to be querying it, but you still will need to use it, basically. You can get around with using some animations, but again, animations in the game have a lot of their very specific properties. It's much more advanced than CSS animations, again, judging by what you will need to use when building the games. Or you might need to do particles in your games, you know, all this like smokes and fires and whatever, and that's also some sort of simulations, just working with a slightly different setup. So, you know, you might say, okay, I'm not gonna use any of that, but believe me, something will pop up that can be attributed to a kind of a simulation. Well, okay, what about input? Input is easy, right? I mean, what's that? You click somewhere and you react to these clicks. Maybe, it depends. I'm not even going to talk about the way you're going to handle the input in the network game when a couple of people interact with each other. Even if you just consider handling input on multiple devices, say your game works on mobile and on the desktop or whatever, it is already a bit of a challenge. And once we get closer to the rendering pipeline and the physics pipeline, we will see that there are actually many more challenges that the input gives itself. It's not, unfortunately, it's not as simple as just getting some events and spitting into the engine. All right, well, we tried. Let's, optimize a bit. We're not gonna build everything from scratch, right? We're just gonna build a framework, or we're gonna use some framework. Let's assume someone built the framework. Just like we did before, right? Very simple example. Nowadays, if you are doing a front-end development, you probably don't interact with the DOM directly, right? Anyone does? Okay, probably not, right? So you use some sort of a framework or a library like React or Svelte or whatever, Vue, Angular, it's up to you. What you do is basically you extract things that are often reused. You establish some conventions, but in the end of the day, you build reusable programmable components, which you just connect together and hope for the best. And look, it normally works, right? So for our beautiful game, what we can do is we can extract all the rendering into the rendering library and do the input library and the simulation library and then some glue code to connect it all together. And maybe with this level of abstraction, it's actually okay. And that's all we need, just a nice, higher level wrapper of APIs. Kinda, but not really. As soon as you start advancing this in your game, you'll need to worry about things like assets, for example. It's fun to create levels with code, right? Up until a very certain level of complexity. Because after that very certain level of complexity, you actually want to create textures in Photoshop and not draw them, solid colors or whatever. You want to place items on the level visually, because again, it's just daunting to move them around, editing some JSON or whatever. And with all of that, you of course need to somehow manage that. Not only use it within the game, but also iterate on that, work somehow, and so on and so forth. And the worst part about that, the worst part is that not only your rendering pipeline will need assets, the physics will need assets as well. You can go pretty far, actually, by using primitive shapes of, just saying, I'm going to compose my human of capsules and spheres, and it's going to be okay. Well, yeah, but you need to place them on a human, somehow. And again, doing this with code is a bit tedious. So in the end of the day, you do need assets, just believe me. And there is also game logic. As soon as you get off, you put the framework code all together and everything's working nicely. Remember, you want to build the game, right? Not the game engine. So you need to write the game logic, how you actually going to complete the level, how you're going to win, how you're going to lose, how, agents going to attack you, and all of that. And, it also has to live somehow together, with everything. Some of you might say that I'm overcomplicating things here, just being the guy in the middle, right? Well, it's very, very easy to see that, unfortunately, that is not the case. So, very basic example. Imagine you get a friend who is a great 3D artist, and he comes to you and you say, dude, you're a great 3D artist, but in order to put the models into the game, you actually need to learn a bit of C++ because it's my great framework, right? It's going to be a bit hard to find this guy. I'm sure they exist, by the way. There are games made by a single person who does everything, but, it's a rare breed. Same applies to sound designers, right? Arguably, the software stacks and the hardware stacks they're using, they're probably, very, very complicated in comparison to the engineering tools we use. But still, they're not engineers, right? Actually, even engineers. That's a quote by Carmack. Little people know, but Quake, the first version, not Quake 3 or whatever, has its own built-in scriptable language. It's called Quake C. for a very simple purpose of just building the game logic. Because again, the engine code is engine code, the game logic is game logic. You gotta build the game. I'm very sorry, that was we all met here today. As you can guess, it starts to look like this, right? Not only you need to create a lot of program components and do a lot of connection between them, you also start to bother about things like how I'm gonna manage the assets, and how the network codes are going to be implemented to work across all the platforms, and so on and so forth. It's just snowballs, basically. And that is true. If we take a look into any modern or relatively modern gaming engines, we're going to find at least a few, very, very basic blocks. So first of all, there is going to be a framework, right? Whatever you're going to be using within this game engine, even on the level of some system plugins, if you please, where you're going to be working with, the rendering pipeline, basically doing kind of low-level stuff, you're almost never going to be interacting with the platform-specific APIs. You're actually going to be interacting with the higher-level abstractions, right? And obviously, when you go to the level of the game logic, you're going to be interacting with the much, much higher abstractions. So the framework is going to be part of that. It's going to be a very important part, but it's just one part of that. A very unpleasant, I would say, for the engineer requirement for the game engine is going to be to have an editor. Yes, I know it sounds like, dude, are you trying to sell front page or something? Like, what do you mean the editor? We got, all these beautiful components, and maybe we just do the plugins to import things from Blender and Photoshop, and it's going to be good. No, you need the editor. Because you need to assemble game levels, because you need your artists and game designers. Even if you are the artist and game designer, you need the place to work somewhere. And this editor is better to have a lot of integrations. Again, very simple example. Your artist created the texture in Photoshop. It would be great to just drop this texture, the PSD file, into the game engine and use it, right? Because it can be converted. And guess what? Not everyone uses Photoshop. There are like a lot of things, right? And this is especially pronounced in 3D modeling software, for example. So if you want to have a decent editor, you have to build all those integrations. Of course, no two games are the same. Well, you can argue that certain games are actually the same, but games, in fact, are very diverse, which means that this editor is better be extensible. Extensible with the code that you're going to be creating, or maybe some guy on GitHub is going to be creating to help you build, I don't know, like curved roads or whatever, but it has to be, extensible in some sort. And of course, it's better be cross-platform. Some people use Windows, some people use Mac, some people use Linux. It's all right. You can go as far with having a web-based editor, but unfortunately, the constraints of, the performance and what is accessible to, your standard web page are gonna block you pretty quick. So it has to be, nowadays at least, unfortunately, better be like a native application that runs on many, many platforms. And as you can imagine, that makes the editor actually a pretty complicated piece of this whole setup. And I can argue that it can be much more involved, at least in terms of the groundwork involved, than the engine code itself. Why? Well, in the end of the day, the editor also has to run your engine inside. Because the picture you're going to be seeing in the editor better be rendered with the same rendering the game uses, for example, and better use the same physics. Otherwise, what you're seeing is not what you're going to get, right? So that makes the editor's bit involved part. You also need the scripting, right? Just we discussed that it's a bit of an excerpt from Quake 1 with the Quake C. You can see it's C, so it's not exactly high level, and you often want a higher level language for the game logic, again, because you don't want to bother with allocations when you decide how much HP points to remove from the user after the hit. But it's your choice. Some engines choose to go with pretty low-level languages, but even then, if you consider Unreal, for example, and you can read that, the Unreal has the C++ scripting. Yeah, that's true, but actually that C++ has so many extensions up to having rolled their own sort of compiler for that it's not exactly C++, it's a very groomed C++. And of course, you need to have that all integrated into your engine. There are many, many more bits, but I'll just put last one because, it's getting like really overwhelming. you want to have the batteries included. You want your game engine to build the game for at least some platforms that you want to support, right? You don't want to create the game for iPhone and then for Android, for console and then for another console, for PC running Linux or Mac or whatever. And of course, with cross-platform builds, you get into the realm of handling all sorts of platform-dependent code. File systems, network calls, you name it, really. That's a lot. Okay, so I know it's escalated very, very quickly to be something, very abstract and sound like a very complex thing, and there are got to be solutions on the market for that, right? Well, guess what? Yeah, there's a ton of them. It's by no means a complete list. I mean, it's not even a complete list of excerpt from the complete list, right? But you can see some familiar names in here. A lot of engines exist. A lot of them do most of the things that I told you before. Some do some things better, some do some things worse. Some things are available for general public, some things are internal. Some things are open source, some things are not open source. There is really like a huge diversity of that. But the fact is that, every modern game engine is actually like a masterpiece because it's a combination of so many great engineering solutions. Maybe not great all the times, but you can always find something at least interesting in some game engines, right? But again, that's all very high level, as we've been discussing here, and it's very hard to even understand where to start, right? So let's draw a novel. You all know this meme, right? It's very easy to draw a novel. You just draw two ovals and then add some details, and here you go, right? So let's focus our attention for today on that very first step. Let's just try to draw two ovals, not a novel. But we will at least hopefully see a pathway forward of how to add details afterwards, okay? More specifically, the rendering. So we'll be considering rendering in 3D, although you'll see that 2D will share many, many properties. And this is actually quite an interesting engineering challenge. First of all, as I told you, in order to handle 3D rendering, you need to know the graphics API, you need to be able to write some shaders, you need to be well-versed in linear algebras, that all holds true, right? But on top of that, you get the time budgets and memory constraints. Think about that. If your game runs at 60 FPS, you have 16 milliseconds to prepare a frame, right? If your game runs at 120 FPS, you have 8 milliseconds. If you're in VR, you just multiply everything by 2 because there are two eyes and you have to do the same job twice, right? So that's a pretty thin time margin, especially given the fact that it's not like you can do something in 16 milliseconds and then chill. After the first frame comes the other frame, so you have to do this reliably within this time budget. Obviously, the memory constraints are also, some sort of a hassle here. If you just take a full HD bitmap, that's 6 megabytes of memory. If you take 100 vertices, which is a model that is big but not huge, to be honest, it's 1 megabyte. And if you mix all of that with the time budgets that you have, you start to get in the realm of very, very interesting numbers. On top of that, you might want to handle some additional bits in your game. Not necessarily, but I don't know what you're building, but you might need to have lights and shadows, right? You might want to place different bulbs on your levels that have different light properties and, they just behave in a different way. You might want to place some mirrors, and mirrors are actually fun because, as Alexa will show us, it's, very simple trick to do a mirror. You just render everything twice, and off you go. But keep in mind, we just talked about the time and budgets and memory, and, now you have to do it again. So, all right. You might want to apply some post effects. Maybe you want your game to look like this beautiful cinematic picture with the color correction utilized by high-profile Hollywood studios. Or maybe you just want to make your picture juicy or color it in a certain way. Different levels, different complexities, but the post effects are a very interesting topic as well. And of course, that's not an exhaustive list again, because, the list is huge. Luckily enough, very soon Alexei will step onto the stage and we'll start drawing novels, and we'll see where it's going to lead us. But before letting Alexei on the stage, let's also briefly touch physics. which is going to be, as you know, the second part of our talk, right? So why physics is interesting? Well, at least I find it interesting. You might call me a nerd, but I think it's fun. So first of all, it's computationally extensive. You'll see the quadratic and cubic complexities everywhere, just because of the nature of the physics. You know, you have objects that interact with each other, and you know, if you need to make sure that any object can interact with any object, it's technically the O(n)2 problem, right? So you will also have to utilize numerical methods. That's yet another beautiful university stuff that you probably skipped, and so that's not going to be used anyway, but actually it is going to be used. But the best part about physics is that it's just generally love. It's very hard to debug. Think about that. If you're working on the rendering and something is not right, the color is off, or the model exploded because your skeletal animation is not right. You know, those who developed the games surely saw this effect. You can at least see what's going wrong, right? You can debug it, I don't know, like step by step, try moving things around until it gets into place, somehow get to the bottom of the issue. With physics, well, you made a ball and the ball drops on the floor and jumps twice as high as it should. Where do you even start looking? Like, you know, there is no point in time where things went wrong. I mean, you can argue it went wrong here or there, but you actually don't know. And of course, you still work in that very same time budgets, because again, your physics has to kind of catch up with rendering, right? And you'll be operating in pretty tough memory constraints as well. Not as tough maybe as rendering, but again, you'll still have the meshes, you still have the assets, you have to manage all of that, and so on and so forth. And Vladimir, I hope you got you at least a bit interesting. Vladimir will show us how to approach this problem and where to start. Okay, so that's it for the opening keynote. I hope I managed to at least kind of set the stage for everyone to understand what we're going to be talking about. And yeah, I'm happy to answer any questions before giving the mic to Alyosha, if you have any.